Hello and welcome to the Unit 1 mock exam for GCSE Foundation Maths. The paper that I gave you was for November 2015. There is one thing to take note of this summer when you're taking your paper, and that is there's a slight change to the header on the front of your exam paper. Nothing to worry about. On all the old papers that you've done so far, you will have had a marks column here where the examiner would have placed all the marks from the various questions. It looks like this has been removed and they've just dedicated the front of the paper to the candidate's details. So the candidate has all this space across the top to place their details. Everything else with the front of the paper is still the same, and we'll go through the details for the paper in a second. For those of you watching the YouTube video who want to just jump to a question they've had issues with, then the shortcuts are provided on the green areas either side of this front page. Let's have a look at the details on the front page then. Unit 1 is for statistics and number. The main thing to remember is it's a 1 hour paper and you can use your calculator, and this is most important. Throughout the paper I will be giving you prompts on when to use your calculator, even for the most basic calculations, so that you don't make silly errors and start throwing marks away. The other thing under materials that you're required to take are your mathematical instruments. So in this paper it's important to take a pencil, ruler, rubber, compass and protractor, just in case you have to draw pie charts. The instructions are pretty standard in all of the papers, where you have to use black ink, answer all the questions, use the space provided and do rough working out in the book, just in case what you're doing is worth some marks. Under the information, the marks for the questions are shown in the brackets, so make sure you've got enough stages to get all of the marks. Don't forget, an answer is only worth 1 mark in exams. It's the working out where most of the marks are. In this paper, there are a total of 54 marks available. That's quite important because with 1 hour to do the 54 marks, it's roughly a mark a minute. So you have to be quite quick through the exam if you want to allow yourself 5 minutes at the end to go through your paper. Your written communication skills will be tested in questions 2, 3 and 14. And those questions will have a little asterisk next to them so that you can see that they require sentences for you to answer the question. So just writing the answer isn't good enough. You have to give a reason for your answer, generally in words and sentences. You can ask for extra paper if required, and the most important piece of advice on this paper is, in all calculations, show clearly how you work out your answer. As we've already said, there are more marks for the working out than if you just put the correct answer on the answer line. Okay, let's start the paper with question 1, and this question is on bar charts, and here we're showing the average daytime temperatures in Morocco. The temperatures are down the left hand side and the months are across the bottom. What you have to remember with bar charts is the width of the bars are the same and there's a gap between each of the bars. Question 1a is asking us to write down the lowest average daytime temperature shown in the bar chart. So when we look across at all the temperatures, we can see that May is the lowest temperature. Now what you need to do is be able to read scales. So between 20 and 25 we have a gap of 5 and 5 minor graduations. So each mark is worth 1. So here we have 20, 21, 22, 23, 24 is the height of our bar. So the temperature in degrees Celsius is 24. It's then asking in question 1b for the average daytime temperature in Morocco in October, which is 25, and asking us to complete the bar chart. Now again, you have to keep the format of what's happened already. So we have a gap of 1, 2, 3, 4, 5 between our months. So you need to allow a gap of 5. 1, 2, 3, 4, 5. So our bar has to start here. And our bars need to be the same width. So counting across the top, we have 1, 2, 3, 4, 5 again. So our bar needs to be 5 wide. So 1, 2, 3, 4, 5. So our bar needs to go between here and up to a reading of 25. So reading across from 25, we need our bar to go roughly around this height. So let's make our bar chart. Okay, so you'll have to forgive my my drawing with my finger on this thing, but that's my bar chart. Now, you don't have to waste time colouring it in. In the exam, there are no marks for colouring in, so you can just shade it like that if you want, but I certainly wouldn't waste 5 minutes colouring in that bar chart grey. Question 1C. Which 2 months have an average daytime temperature between 26 and 30 degrees C? So really you need to go back to your bar, look at 26 and look at 30 and spot which temperatures fall between those two bands. Well, I can see June falls between 26 and 30 and the other month is September. So June and September on your answer line. Question 1D. In July, the average temperature at night in Morocco is 19 degrees centigrade. How much lower is this temperature than the average daytime temperature in Morocco in July? So it's asking us to read our temperature in July, so we go to our bar chart and we read off a temperature of 31 degrees. So it's 31 during the daytime and we have to take off the 19 degrees at night. Again, you can do this on your calculator just to make absolutely sure you don't make any mistakes, and it's 12 degrees. So the difference in Celsius between daytime and nighttime in July is 12 degrees C. Question 2. 50 raffle tickets are sold for 25 pence each. The winning ticket is picked at random. Linda buys 14 tickets. She pays with a £10 note. How much change should she get? So question 2A is asking us to calculate how much change. So she buys 14 tickets and they are 25 pence each. So in maths we make pennies in decimals, so 25 pence is 0.25. So show the examiner what you're putting into your calculator. You should have as an answer £3.50. Now the question is actually asking us how she pays with a £10 note, how much change we're interested in. The alarm bell should be ringing in that it's worth 3 marks. So we have £10 and we need to take off £3.50. And this should leave us, again, use your calculator if you don't want to make any mistakes, £6.50 in change. So I would write here £6.50, and taking note of the asterisk on this question, in change. I would just add the words at the end. Question 2b. Write down the probability that Linda buys the winning ticket. Well, probabilities is the outcomes that we're interested in. So she has 14 tickets and we divide it by the total number of outcomes. So there are 50 tickets in the draw. You could leave it like this, or knowing what we do now about fractions, we could simplify it to 7/25. And that would be my answer. So 7/25 is the probability. Question 2c is asking us to work out the probability that Linda does not buy the winning ticket. Well, the probability of something not happening is 1 minus the probability of it happening. So we know the probability of a winning is 7/25. 1 can be written as 25/25, because when I divide 25 by 25 I get 1. Take away 7/25 and you should get 18/25. And write this on your answer line. So 18/25 is the probability that Linda does not buy the winning ticket. Question 3, and this involves a table showing the number of people going to the gym in the day. And it's split up into various times of the day. The most important thing on the pictogram is the key. So here it's telling us the circle is worth 2 people. So when we check our first time group, we have between 7 and 09:59, 2, 4, 6, 8, 10, and then this one gives 11 people, which ties in with what we're seeing in our table. And what they want us to do is to complete the pictogram. So let's complete the pictogram. With one person, well, if a circle represents 2, we need to draw half a circle to represent one person. To represent 4 people, then it's 4 divided by 2, so it's 2 complete circles. To represent 6 people, it's 3 complete circles. And then finally 9 people, well, 4 circles is 8, so that's 2, 4, 6, 8 people, and then half a circle for the 9th person. And that completes our pictogram. Question 4. The table shows some information about a car hire. It also shows some extras to do with the car, and what we're given here is a specification for Tracy, who wants to hire a car. And we have to work out the cheapest total cost. So the way to address this is look at her specification and see what we can get for her, keeping the cost as low as possible. So let's start off with our 5 people. Well, we can't use the small car because it only takes 4. So we have a choice of cars, the medium or the large. So the cheaper one is the medium, and it's a cost per day. Now she wants the car for 7 days, so it's £17.31 multiplied by the 7 days will give us our total just for the car hire. Again, use your calculator in all calculations. So that's £121.17 just for the car hire. Now it says that she wants car insurance, and insurance is per day, so again we need to multiply it by 7 to work out our total insurance. Again, use your calculator, don't take any chances. And that's £52.50 for the insurance. And then finally we need a baby seat, and this is per week, so we only have to add the £39.60 to what we already have. Again, using a calculator, make sure you don't make any mistakes and add your car hire to your insurance and your baby seat. and you should have a total of £213.27. And this is what they want on the answer line. So £213.27 on our answer line. Question 5 is a pie chart question about government spending. Question 5a wants us to calculate the percentage on spending on pensions. So pensions is here, and we have a variety of answers we need to circle. Now, the percentage is our angle divided by 360 times 100. Now, you should be able to recognise that because of the square having our angle, that's 90 degrees. And because it's only 1 mark, you don't have to show how you get the percentage. All you need to be aware of is that 90 degrees is 1/4 of our circle, and 1/4 is represented by 25%. Question 5b is asking us to calculate the angle of the sector for schools. So the schools sector hasn't got an angle in it, and that's what they're asking us to calculate. So we know a circle has 360 degrees, and essentially what they're asking is to take away all the other angles that they have given to find out the angles for schools. So we need to take away 81, 90, 87, 33 and 42. And when we take those angles from 360, it should leave us with our angle for schools. Again, use your calculator and don't take any chances. And you're left with 27 degrees as your answer. So place the 27 on the answer line. Question 5c is asking us to work out the ratio of spending between health and police. An important thing here is it wants its answer in simplest form. So health to police is as it's written in the question, so that's how we have to write it down in the answer. So our health is 81 degrees and our police spending is 42 degrees. And what we need to do is work out if there are any common denominators to these two numbers to allow us to divide both sides and simplify it. So if you look at your factors for, let's say, 42, you have 1 and 42, 2 and 21, 3 and 14, 4 doesn't go into it, 5 doesn't go into it, 6, and 6 goes into it 7 times. And then what you need to do is something similar for 81. So the factors of 81 are 1 and 81. 2 doesn't go into it, 3 goes into it 27 times. 4 doesn't go into it, 5 doesn't go into it, 6 doesn't go into it, 7 doesn't go into it, 8 doesn't go into it, but 9 goes into it 9 times. 9 nines are 81. So all your factors are there, so you can see on both sides that both 42 and 81 are divisible by 3. So when I divide them by 3, I end up with 27 on this side and 14 on that side. So my ratio of spending for health to police, simplified, is 27 to 14. So not just a ratios question, but a simplifying question and a question on factors. Question 6 is a stem and leaf diagram where it's giving us the heights of men and women. The stem and leaf has been ordered for us, and we have our key here showing that 17 bar 2 represents 172 centimetres. So in this instance, our stem isn't just representing tens, it's representing tens and hundreds, with our leaves representing the units. So question 6a is asking us, for the men, which average is 161 centimetres? So going across to the men and looking at 161 centimetres, could it be the median, mode or mean? Well, the median is the middle value, and unfortunately for us the middle value is in here somewhere, so it can't be the median. The mode, well, it could be the mode because 161 occurs most often, so it's very probably the mode. Because also the mean we would expect to find in the middle of our values somewhere as well. So let's say that 161 can only be the mode. Question 6b, work out the median height of the women. So the median is the middle. Now we know we have 20 women, and when we have an even set of numbers and we're calculating the median, there are two middle numbers. So when we divide 20 by 2, it gives us 10. So our 10th value is going to give us one of our two values and our 11th value. So we need to work out the average of our 10th and 11th values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our 10th value is 162, and we need to add our 11th value, which is 164. And when we add those two values and divide by 2, we end up with 163 centimetres. So our answer for our median height of women is 163 centimetres. It's then asking us to calculate in question 6c the range of all 40 heights. So the range is the highest value against the lowest. So let's look at the lowest value for men. So the smallest man is 157 centimetres. The smallest woman is 153. So our lowest value is 153 centimetres. Now let's look at our tallest man and woman. So our tallest woman is 184 centimetres, however our tallest man is 205. So our highest value is 205 and our lowest value is 153. And this gives us, again, doing the calculation on a calculator, 52 centimetres as our range for all 40 people. Question 7 is looking at a two-way table of 40 students with various colours of their eyes. And they've given us a couple of clues to help us complete the table, which is what they're asking us in question 7a. So half the students with brown eyes are boys. So this is saying that 18 can be divided by 2 to say that 9 boys have brown eyes, which leaves 9 girls with brown eyes. The second bit is saying that there are 6 more girls than boys in total. So we know our total is 40, and if there was an even split, there would be 20 boys and 20 girls. However, it's telling us that there are 6 more boys than girls. So what we need to do is, for girls, we need to add 3 to our 20 to give us 23 girls, and subtract 3 to get the number of boys. And now you can see, if I take 17 away from 23, I have our 6 difference. So we have 23 girls and 17 boys. And with those two bits of information, I can now complete the rest of my my table. So 9 plus 3 is 12, so I need another 5 to make up my 17. 9 plus 2 is 11, which means I need another 12 to make up my total number of girls as 23. And now I can add across the way, so 3 plus 12 is 15, and then 5 plus 2 is 7. And as a final check, you should really add down the total to make sure you get 40. So 18 plus 15 is 33, plus the 7 gives us the 40. And that was worth 4 marks. Question 7b is asking us what percentage of the students have brown eyes. Well, as a percentage, we have 18 out of our 40. So what you can do is have 18 divided by 40 times 100%. Don't forget, this is a calculator allowed exam. So on your calculator, 18 divided by 40 times 100 equals 45%. Question 8a. An ordinary fair dice is rolled 420 times. How many times would you expect the number 3? So this is expected frequency, which is our probability times the number of times we do something. So the probability of rolling the number 3 is a 1 in 6 chance, because there's one number 3 on a fair die. And then we need to multiply that by 420 to work out the number of times we would expect to see the number 3. Now this is one of those instances where if you delete the 6 from there and do this first, it will give you a nice round answer, because we know that 1 over 6 is a recurring decimal, and it will leave a remainder when we do the calculation with the 420 over here. So here, if we divide 420 by 6, we end up with 70, and 70 times our 1 that we had already gives us an answer of 70 times. So we'd expect to see the number 3 70 times in 420 rolls. Question 8b. A bias dice is rolled 50 times. The number 5 appears 23 times. Which of the following give the correct relative frequency of the number 5? Circle all the correct answers. Well, we have 23 times that we saw the number 5 out of 50 rolls. So the relative frequency is the number of times we actually see something divided by the total number of times we do the rolling of the dice. So 23 over 50 is our first answer. Now, we have two choices for percentages. So the easiest way to turn this into percentages is multiply the top and the bottom by 2. So we have something over 100, which represents a percentage. So we have 46% as our second option. And then our final option as a decimal is we have to divide 46 by 100. So in theory, we're moving the decimal point 2 decimal places, and we end up with 0.46 as our decimal answer. So for our 2 marks, there are 3 options: 23 over 50, 0.46, and 46%, which are all the same number, just written in different formats. Question 9. This is a question with a frequency table, and what we have to do in question 9a is show that there are 24 questions. So the number of questions is this column. So essentially it's asking us to add 7, 10, 4 and 3 to get 24. So I would show them in my working out. That's what I'm doing. Again, use your calculator if you're not sure. Question 9b is asking us to work out the mean number of marks per question. So what we need to do is multiply the number of questions by the marks allocated for those questions. So if 7 questions have 1 mark, there is a total of 7 marks. If 10 questions have 2 marks, then it's 2 times 10, which means there's 20 marks on offer from those 10 questions, and so on. So 4 questions at 3 marks is 12 marks, and 3 questions at 4 marks is another 12 marks. So the total number of marks on offer from our exam paper is 51. Again, use a calculator to add these numbers up. Now we haven't quite finished, because 51 is the total number of marks, and they're spread over 24 questions. So 51 divided by 24 will give us our mean. And that is 2.125 marks per question. Don't do any rounding, put the answer down as you have it on your calculator. And that was worth 3 marks. Question 9c is also about our frequency table, and it's more to do with understanding the mean of some numbers. So the mean of the marks per question is now 20 after an extra question is added to the test. So using our mean triangle, we now have a mean of 2.2, and it's made up of 25 questions. And this will give us the sum of all our marks. So 2.2 times 25 gives us 55. And again, do this on your calculator. We know from the previous question that the total number of our marks for 24 questions was 51. So the extra question that has been added is worth 4 marks. Question 10. Ben wants to find out which type of music people prefer, and he surveys 10 boys in his class. Write down one way that Ben can improve his survey. Well, the obvious one, and it's only 1 mark, is ask more people. And it doesn't have to be restricted to boys in his class. It could be ask the girls in his class, ask some of the teachers, and so on. But for 1 mark on a straightforward question like this, don't overthink it. They're asking you to state the obvious, which is ask more people and your survey will improve. Question 11 is a scatter graph, and it's about a teacher recording the number of lessons missed by 30 students. And she's compared the number of lessons they've missed with the results in a test. The percentage of their test results is on the left hand side, and the number of lessons missed is across the bottom. And basically the first part of our question 11 is asking us what type of correlation. Well, you should be aware that positive correlation is a line like that, and negative correlation goes the other way. So in this instance, it's quite straightforward to see we have negative correlation. Now in this case, they're asking just for the type of correlation, and negative gets you the 1 mark. But if you want to say it's strong as well, then you can add strong negative correlation, and it won't make a difference to the mark in this case. So continuing with question 11 and our scatter graph, it's asking us to draw a line of best fit. Now it's really important that your line goes through the middle of all the points. It doesn't have to touch any particular point, but it's got to go as close to all of them as possible, because the next part of the question, where we read information from our best line of best fit, will be off and we could end up dropping marks. So let's place a line of best fit onto our graph. So can you see how I've tried to place the line as close to as many crosses as I can without trying to put it through a particular cross, and having a balance between the number of crosses above and below the line. So that's my line of best fit drawn, and I believe that's worth the 1 mark. Now question 11c is stating that another student missed 40 lessons. Use your line of best fit to estimate her result. So we need to go to 40 on our line graph and draw a straight line up to our line of best fit. So let's do that. Okay, there we go, our line of best fit. And then what we need to do is we've drawn our line from 40 up to our line of best fit, and we need to read this value off our left hand side. So before we read the value, it's about scales. So we have a gap of 20 between our two major markers, and we know that we have 10 divisions between those two markers. So each smaller mark is worth 2. So here we're at 60, 62, 64, 66. So I believe the student who's missed 40 lessons will get a percentage of around 66%. And there is a bit of leeway in the answer depending on where your line of best fit is, but it's not massive because it roughly goes between 62% and 70%. So if you're outside of those, you will drop the marks because your line of best fit is not in the correct place. Question 12. There are 20 coloured balls in a bag. The probability of choosing red at random is 1/4. One more red ball is added. Work out the new probability of choosing a red ball. So we have how many red balls in our initial bag? Well, it's 20 balls times 1/4 gives us 5 red balls. Now we add an extra ball into the bag, which is red, so we now have a total of 6 red balls. However, we now have 21 balls in the bag. So our probability is 6/21, which we can simplify by dividing the top and the bottom by 3 to get 2/7. So that's a bit of simplification by dividing the top and the bottom by 3. So our probability of choosing a red ball is now 2/7. Question 13. 3 positive whole numbers have a mean of 6. What is the greatest possible range of the 3 numbers? Well, if you have a mean of 6 with 3 numbers, then the sum has to be 18 for our 3 numbers. It's our mean triangle, where the mean is 6, the number of numbers is 3, so the sum is 6 times 3, giving us a total of 18. So we know our numbers have to add up to 18. We're trying to create the biggest range possible. So the lowest number, if we say is 1, would give us a top number of 17, but we need another number. So there's no reason why we can't have 2 1s. So if we take the 2 1s away from 18, it leaves us with 16. So our 3 numbers could be 1, 1 and 16 because they're 3 positive whole numbers. When we add the 3 numbers together, we get 18, which when we divide it by 3 gives us our mean of 6. So to work out the range, so remember what they're asking for, we have 16 as our highest number, 1 as our lowest number. So the biggest range we can create with those 3 numbers is 15. Question 14 is asking us about ratios and boxes with apples. And in box A we have a ratio of apples of 5:7, and in box B it's telling us as a fraction, or sorry, as a proportion, that 2/5 of the fruit are apples. So really what we're comparing is a ratio to a proportion, and they want to know that you understand how to compare a ratio and a proportion and put them in the same format. So let's look at box A first. And box A has 5:7, and it's apples to oranges. Now, as a proportion, we have to know the total number of parts, which is 12. So the number of apples in box A is 5/12. So it's now written as a proportion. We know that in box B, we have a proportion of apples, which is 2/5. And what we need to do is to compare. So this is a question on equivalence of fractions. So I need to put the apples in box A and the apples in box B with the same denominator so I can compare the two to find out who has the most. Now the number that is common to 12 and 5 is 60. So they both need a common denominator of 60. So to get from 12 to 60, I've multiplied it by 5, and I need to do the same to the numerator to keep the fraction equivalent. So 25 over 60 is exactly the same fraction as 5 over 12. I need to do the same over here with box B, where to get from 5 to 60 I've multiplied it by 12. So when I multiply the numerator by 12, I end up with 24 over 60 as my equivalent fraction. And now I compare like with like. I have 25 over 60 for box A, 24 over 60 for box B. So we need to write something in words because it's got an asterisk. So you would write something along the lines of box A has more apples as it has a proportion of 25 over 60 as opposed to box B which has a proportion of 24 over 60. And that concludes the questions for the Unit 1 Foundation mock exam for November 2015. I hope it was of some use to you. This was an Archie the Pooch production as always, and I wish you the best of luck in your exams. If you have any problems or questions about the video, then please don't hesitate to get in touch.